Hello, good day, viewers. Since I started this topic, trigonometry, I have been using degrees to represent angles. But you should know that angles can either be represented in radians or degrees. So in this tutorial, we are going to learn the relationship between radians and degrees. So let me start with radians. Suppose we have a cycle like this. This is not perfect. We have the center of the cycle. Remember that this part here is what we call the circumference, and from the center to any part of the circumference is called the radius. So if I should join this to this, we call this r. Now I would like to travel a distance from this point of the circumference where our radius touches the circumference, clockwise or anti-clockwise, a distance of r. So I would like to travel like this, such that this length of an arc is equivalent to the radius, so they will have the same length. If this is 7 centimeters, this must be 7 centimeters. The arc length will be 7 centimeters. And I can confidently connect this point to this point. This will remain radius because the part of the circumference to the center is a radius. So whenever you have this situation where you have two radii subtend to the circumference to form an arc in such a way that that arc is also equal to the radius, then the angle subtended must be 1 radian. So this angle here formed by these two radii will be 1 radian. This is how to write radians, and a radian without x. All right, this is just a short form. But the question is, how many of this arc equivalent to radius can we have around the cycle? That's another question, because we want to establish a relationship between radian and degrees. Because if this angle can now be equal to 1 radian, what will it be in degrees? So you should know that C, which is the circumference of a cycle, is equal to 2 pi r, right? We all know this. This is the formula for finding the circumference of a cycle. But we know that if we should join this r around a cycle, it will be equivalent to the circumference. But we don't know the number of r's. This r here is for arc. We don't know the number of these arcs we are going to have around a cycle. But since we don't know, I can use a variable to determine, I can use n number of r's. So another circumference is equivalent to n number of these arcs. Yes, definitely. So if you relate these two equations, you can see that since they are all expressed in terms of c, you can equate their right hand side. Therefore, nr is equal to 2 pi r. If r cancel r, we have n equal to 2 pi. But remember, I said that n stands for the number of these arcs. So therefore, you have 2 pi number of r around the cycle that have this condition, 2 radii equal to an arc equivalent to the radius. But this is not our point of interest. We would like to find out how many of this 1 radian can we have around the cycle. For instance, we could have another one here. Let's assume this is also r, this is r, we can have another one here. If this is r, this must be r. So how many r's do we have? We have seen that it is equivalent to 2 pi. So if this is 1 radian, this is another one, this will give us 3 radians, right? So we want to find out how many of these we're going to have. So if r is 3, we have 3 radians. Therefore, if r is equal to 2 pi, we are going to have 2 pi radians around a cycle, right? Therefore, the total angle around a cycle is what? 2 pi radian. 2 pi radian. But we know that around a cycle, we have 360 degrees. Therefore, 360 degrees is equivalent to 2 pi radians. Therefore, 2 pi radians is equal to 360 degrees, right? You know that half of 360 degrees is 180 degrees. Therefore, if you divide both sides by 2, you have pi radian to be equal to 180 degrees, which implies that the total angle at a point or on a cycle is 2 pi radian. And half, that is the diameter. For instance, if you have this, from here to here, we know it's 180 degrees. So it will be equivalent to pi radian. So let us write that formula connecting radian and degrees. From here, we may decide to divide both sides by pi. So this is the most important equation. So if you divide both sides by pi, you have 1. Pi divided by pi is 1. So we have 1 radian here, equal to 180 degrees divided by pi, because we divided both sides by pi, which means that this formula here, it is the conversion scale. If you're given 1 radian, you should know that it is equivalent to 180 degrees divided by pi. And this pi, you know, approximately it is equal to 3.142, right? So if you like, you can write it in decimal by dividing 180 by 3.142. So what if you are given 10 radians to convert to degrees? You can multiply that 10 radians by 180 degrees divided by pi. What if it is pi radian? Though we have it here, if it is pi radian and you wish to convert it to degrees, this is equal to that pi multiplied by 180 degrees divided by pi. You see this pi will cancel this pi. Eventually, you have 180 degrees. So whenever you are given an angle in radian to convert it to degrees, use this scale factor. Multiply that by 180 degrees divided by pi. But what if you are given degrees and asked to convert it to radian? So from here, you can divide both sides by 180. So if you divided the other side by 180, it becomes 1, right? You divide this by 180, it becomes pi divided by 180 radians. So this is 1 degree, right? Every single degree is equivalent to pi divided by 180. So if you are given, for instance, 60 degrees to convert it to radian, this is what you need to multiply that 60 by pi divided by. So let's try it and see. For instance, if you are given 60 degrees to convert it to radians, it will be 60 degrees multiplied by pi divided by 180. And you know that how many? Okay, this 0 will cancel this 0. 6 into 18 will give us exactly 3. So therefore, 60 degrees is equal to pi divided by 3 radian. So pi divided by 3 is equivalent to 60 degrees. So if you are given an angle in degrees, to convert it to radians, multiply that by pi divided by 180. If it is in radian, multiply that by 180 divided by pi. As simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. In our next tutorial, we are going to convert different degrees to radians, radians to degrees. Bye-bye.